When p-type and n-type silicon are placed in contact with one another, it forms a p-n junction. At this junction, an interesting phenomenon occurs that is the foundation of solid-state electronics. A basic p-n junction creates a diode that allows electricity to flow in one direction but not the other. We can see in the diode that the n-type material has free electrons and the p-type material has holes. Near the p-n junction, the electrons diffuse into the vacant holes in the p material, causing a depletion zone. This depletion zone acts like an insulator, preventing other free electrons in the n-type silicon from combining with the holes in the p-type silicon. In addition, this leaves a small electrical imbalance inside the diode. Since the N region is missing some electrons, it has obtained a positive charge, and the extra electrons that fill the holes in the P region have given it a negative charge. Unfortunately, one cannot generate power from this electrical imbalance. However, the stage is set to see how the p-n junction functions as a diode. Now let's connect the diode to an external power source, a battery with a light and a current meter that indicate current flow. The negative terminal of the battery is connected to the n-type silicon. We know that like charges repel, so the free electrons are pushed toward the p-n junction. Similarly, the holes are repelled by the positive terminal of the battery toward the p-n junction. If the voltage pushing the electrons in holes has sufficient strength to overcome the depletion zone, approximately 0.7 volts for a typical silicon diode, the electrons in holes combine at the junction and current passes through the diode. When a diode is arranged this way with a power supply, it is said to be forward biased. In this example, the battery is connected so the negative terminal of the battery connects to the p-type silicon and the positive terminal of the battery connects to the n-type silicon. The negative terminal attracts the positive holes in the p-type silicon and the positive terminal of the battery attracts the free electrons in the n-type silicon. All the charge carriers are pulled away from the p-n junction, which essentially creates a larger depletion zone and no current flows. When a diode is arranged this way with a power supply, it is said to be reverse biased. The p-n junction is referred to as a simple diode. A diode is a semiconductor component that has two leads, an anode and a cathode. The anode is the p-type material and the cathode is the n-type material. When drawing a diode in a schematic, the anode is the arrow side of the symbol and the cathode is the side with the line. The diodes that you see in the lab may vary to some degree. However, most diodes are black with a white band on one end indicating the cathode of the diode. It's very important to know what end is the anode or the cathode so you will know if the diode will be forward or reverse biased. A diode that is placed in a circuit with the anode toward the positive terminal of the power supply is known to be forward biased. A forward biased diode will only drop 0.7 volts and the other components will drop the remaining voltage supplied by the power supply. A diode that is placed in a circuit with the anode towards the negative terminal of the power supply is known to be reversed biased. A reverse biased diode will drop all of the circuit's applied voltage until the reverse breakdown voltage is reached, at which point the diode will fail. Diodes are a very versatile semiconductor that have many uses and are seen throughout the electronic industry.